Hello friends, in this video we are going to see the next lesson, that is coordinate geometry. You may wonder what is coordinate geometry. First we will see what is coordinate geometry and we will proceed then further. First, you may all have seen the x-axis and y-axis in your lower classes, and the right side is the x-axis and this is y-axis. The negative side is represented as the opposite side, that is x dash and y dash. So this is the representation of the coordinate geometry, the Cartesian plane. Then we take a random point A on the axis. Let's say this point be 5 comma 3. So this point represents that 5 distance from the x-axis from the origin and 3 distance in the y-axis from the origin. So the coordinates of the point A is 5 comma 3. Now we know that in previous classes we have studied that the x-axis point is known as abscissa and the y coordinate point is known as ordinate. So in this 5 is abscissa and 3 is ordinate. So we should all remember that always we should write the abscissa first and next only we have to write the ordinate. This is the order that we have to follow. Now we will take another point B such that its coordinates are 4 comma minus 2, as it is in the fourth quadrant. X is positive and y is negative. Now there are 2 points A and B. So first we will see about the distance formula, that is to find the distance between A and B. So for that we use the distance formula to find the distance. But before going to the distance formula, we have to see another important thing, that let's first mark x all the axes, and now we see this is the first quadrant as second quadrant, third quadrant and the fourth quadrant. In the first quadrant both x and y are positive. In the second quadrant x is negative and y is positive. And in the third quadrant both the axes are negative, and in the fourth quadrant x is positive and y negative. This is very much important for us to know. So now we will take the point A as x comma y, which should be in any one of the axes, and we should know the sign convention correctly. Now we will take 2 points and we'll discuss about the distance formula. Say let A be x1 comma y1 and b coordinates be y2 x2 comma y2. Now the distance formula AB is given as square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is how we find the distance between the two given points. The coordinates are used to find the distance between them. Now we will take a sample number and we will check out the distance. Let us say A be 2 comma 3 and B point B 4 comma 5. So we will find the distance by substituting the values in the formula. So 4 minus 2 the whole square plus 5 minus 3 the whole square. So by solving it both gets 2. So squaring of 2 is 4. So 4 plus 4 we will get as root 8. So root 8 we can write as 2 root 2. How we can write it as 2 root 2? By 8 can be written as 2 into 2 into 2, which means 4 into 2. So root 4 is 2 and then we get 2. So it can be written as 2 root 2. So the distance between A and B point is 2 root 2 units. So this is the distance formula. It's pretty much easy. Just by substituting we can get it. So next we are going to see about the section formula. In section formula, that is 2 points will be given, and by joining those 2 points you will get a line. That is, let's see with an example. A and B are the 2 points, are the end points of the line. Let us say the coordinates of AB x1 comma y1 and BB y1 x2 comma y2. So these are the coordinates, and we will take a point P on the line AB. This P point has a coordinates x comma y, and this x comma y is unknown. We can find the x comma y value by using the section formula, but for that we must know what is the ratio that this P point is dividing A and AB line. So that ratio would be given as m1 and m2. So these are the ratio by which the P is intersecting the line A and B. So we can find the coordinates of P by using the section formula, that is P coordinates of P, that is P of x comma y is equal to m2 x1 plus m1 x2 by m1 plus m2, comma m2 y1 plus m1 y2 by m1 plus m2. So by using this formula we can find the coordinates of P. The simple way to remember is that for the second coordinate we must multiply with the first ratio, and for the first coordinate we must multiply with the second ratio and sum it, and the denominator is the sum of the ratios. So by doing this we can find the coordinates of the point P. Now we will solve a sample problem to understand this section formula in a much better way. First we will draw a line AB, A with the coordinates of 2, 3 and B with the coordinates of 4, 5, and the P is the point sectioning the line with the ratio of m1 is equal to 2 and m2 is equal to 1. So the ratio is 2 and 1. The point P is cutting A and B. Now we will do with the section formula. Coordinates of P is equal to using the section formula we write it as 1 into 2 plus 2 into 4 by sum of the ratios, that's 2 plus 1 3. Then with the y coordinates 1 into 2, 1 into 3 plus 3 2 into 5 by 3. So by adding the numerator we get 10 by 3 comma 13 by 3. So the coordinates of the point P are 10 by 3 comma 13 by 3. So this is the usage of the section formula. There is also a special case in the section formula when both the ratios are equal to 1. That time it becomes the midpoint theorem. The midpoint theorem may be given as a separate topic in your syllabus, but it is just a special case of the section formula. That is when both the ratios are 1. In this case we have taken m1 as 2 and m2 as 1. Let's suppose we take m1 also as 1. That time the new denominator becomes 2. So this becomes the midpoint theorem. By midpoint formula it is given as coordinates of P is equal to x1 plus x2 by 2 comma y1 plus y2 by 2. So this is how the section midpoint formula is being derived from the section formula. So you can remember this, or you can anytime substitute both the ratios as 1 and get the midpoint formula. So it's just a special case, so it's not necessary that it's a big topic, that's all. So this is the midpoint theorem. Now we will go see the last topic, that's the area of a triangle. So in this area of a triangle we all know that is equal to half into base into height. So now we draw a triangle. In this is the height and this is the base. So we all know that this half into base into height is gives the area of this triangle. In coordinate geometry also we get the 3 points are given in the question to find the area of the triangle. In this sometimes the collinearity also comes in place, where all the 3 points are in the same line. That time the triangle won't be forming. So that we will see that is 3 points are given in the question. If these 3 points lie in the same line, they don't form a triangle, so the area will become 0. But for getting a triangle, we need 2 points in a line and another points in some other line. So that is collinearity. We will see that later. Now we will see about the area of the triangle. For finding the area of the triangle in coordinate geometry, a special formula is being given by using the half into base into height triangle. They have derived the formula is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is the formula for finding the area of the triangle when all the 3 coordinates are given. This x1, x2, x3 are all that is, assume that a is the coordinates of a is x1 comma y1, coordinates of b is x1 comma x2 comma y2, and coordinates of c are x3 comma y3. So by this we frame this. Now we will solve a sample question to understand that the coordinates of the triangle coordinates of the points are 2 comma 3 minus 1 comma 0 and 2 comma minus 4. So we need to find the area of the triangle formed by these 3 points. For that, by using the formula, area of triangle is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So by substituting the values in the formula, we get half into 2 into 0 plus 4 plus minus 1 into minus 4 minus 3 plus 2 into 3 minus 0. So by solving this, half into 8 plus 7 plus 6. So by adding it we get 21. So the area of the triangle will be 21 by 2 square units. We see that the area of the triangle formed by these 3 coordinates is 21 by 2 square units. But by this we come to know that all the 3 points lie in this different plane. But if this is collinear, the area formed by the triangle will be 0. That is, we can't form any triangle. So that time the collinearity comes into play. We may start this question by not knowing that if these points are collinear or not. So while solving, if we get area as 0, we must conclude that the area is not there, so these points are collinear. And if we get some other value, then it would be a non-collinear points, and that is the area of the triangle. So that's all with coordinate geometry. We'll see in the next video. Thank you.